Alright, welcome back. So now we're going to be looking at how we can use our tree diagrams to help us determine probability. So with this particular lesson, we need to look at different events and then interpret what they mean when we come to chance events that we're interested in. So let's start it. So a coin is flipped and then a die is rolled. How many total outcomes are shown in the tree diagram? So we can have coin, we can have die, and we can have outcome. So, starting off, we're going to start out with our die outcomes because they'll take up a lot of room. Right, and then our coin outcomes only have 2. So after that, you can draw in all of your lines. And then you can add in this starting little section if you want. You don't have to. Right, so once we've done that, we have all outcomes. So outcomes are going to be H1, H2, H3, H4, H5, and H6. And then the same for tails. Right, so all the outcomes are there, and we can see that we have 12 total outcomes. Now, our second question, 12 total. Our second question asks us, find the probability of getting a heads and a number greater than 4. So, we need to remember that AND means they have to have both of these characteristics. It has to be heads and a number greater than 4. It's not a heads or a number greater than 4, it's both of them simultaneously. So when we look at these, what are our favorable outcomes? Well, our probability of this occurring, heads and greater than 4, is going to be equal to our favorable outcomes divided by our total. So our total is 12, and our favorable outcomes. What are heads and greater than 4? Well, it's only these two here. So it's 2 out of 12, which is equal to 1 out of 6. Alright, find the probability of getting tails and an odd number. So we know that our probability is going to be tails plus odd is going to be equal to something out of 12, because that's our total amount of outcomes. And our tails and odd numbers are only going to be T1, T3, and T5. So there's only going to be 3, which means I have a 1 in 4 chance of getting that particular outcome. Alright, here's another one to practice. So we have a spinner and it has 4 equal sections. It has red, blue, and green, and yellow, and it is spun twice. So we can do red, blue, green, and yellow. Red, blue, green, and yellow. Red, blue, green, and yellow. And then right, and this is our kind of our very short or very small version of a tree diagram. It does functionally the exact same thing, and all I'm doing is just showing you that you can conceptually get the same outcome. All you have to do is rewrite it. So our possible outcomes are going to be red, 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 blue, red, green, red, yellow, and then blue, red, blue, 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 green, and blue, yellow, and then green, red, green, blue, green, green, and green, yellow, and finally we have red, yellow, red, yellow, blue, yellow, green, and yellow, yellow. So those are all outcomes. Now I know I was trying to save space, but obviously, if you do this in one line, it takes up a lot of room. So, how many total outcomes are there? There are 16. Alright, 4 groups of 4 mean there are 16 total outcomes. Alright, what about B? Find the probability of getting G and then Y. Well, how many of them are these outcomes are G and then a Y? Well, we have a G and a Y. Is there anything else that can possibly fill that? No, so really we only have the probability of getting G then Y is 1 of 16. Right, C, what's the probability of getting 2 of the same color? Well, let's have a look how many times that occurs. So red, red, blue, blue, green, green, and yellow, yellow. So only 4 times. So probability same color is equal to 4 out of 16, which is equal to 1 in 4. Alright, that's it for this video. Hopefully it's helpful, and I will see you in the next one.